update software, do all of these fancy things. And then you have to do all of these things. Thank you very much for staying in. I'm going to just put up the slides while I'm going through the presentation because we have lost a bit of time and there's people already that are in the room. So I just need to do an introduction as I'm putting up the slides that we're going to go through. This particular training webinar, you'll notice that it's part of a series that we are starting now. It's going to be a series of 12 webinars. I'm the first of the different presenters that are going to come in. These particular webinars are dedicated specifically, the word BIN stands for Building Inspectors Network. So these webinars are targeted and focused on the build environment or the building environment, specifically as it relates to construction and building inspections. It's a series of 12. The first one has part 1 and part 2. Part 1 of the sustainability is going to focus on the energy management and the energy field. And then we're going to have part 2, and part 2 will be driven by a different presenter. And these training webinars are very short. They're meant to last for about an hour. If they go over, they'll probably go to a max of 90 minutes. The first 30 to 45 minutes, it's a presentation on the technical topic. And whoever will be presenting that is a format of a master class. Whoever will be presenting on the basis of that topic. And the topic range from energy management, as we're going to talk today, and then all the way to, I know I've seen the program, the team have shown me the program. There's a topic on roofs, construction of roofs, roof designs. There is a topic somewhere on fire safety, and fire security as it relates to buildings and so forth. So the foundations, windows, doors, and glazing. So each one of them is going to focus on a particular topic and a specific topic, and an expert in that field. I'm not an expert in roofs, so you're not going to see me when they talk about roofs or other aspects. And so this particular first one, I felt that we need to start off by just laying the foundation in order to understand the different expertise that will come in with regard to this. It's a slightly different type of webinar where it's unlikely that you'll see a panel. In most of these webinars, all 12 of them, an expert will arrive and they'll give a short master class format of whatever topic or technical topic they're dealing with. And at the end, they'll allow for Q&A. As I said, most presentations will be 30 to 45 minutes. And then after that, there'll be time for the Q&A. That Q&A has been allowed for the first 15 minutes to take an hour. It can go all the way to about 90 minutes, depending how interesting or least boring the topic is. And today's topic is on sustainability. And then what will happen is I'm going to take you through a presentation with regard to this particular topic. And then that particular presentation, we're going to go straight into it. So the topic for today is sustainable building practices, and part 1 deals with energy standards. And I'll go through it, and at the end, we'll allow Q&A with regard to the questions that may arise as it relates to this particular presentation. My name is Mashilo Pitjeng. I am the director for the Academy of Construction and Real Estate. Academy of Construction and Real Estate is an institution that focuses on continuing education and career training. As a result, our focus with regard to professional development focuses on professionals and professionals that are either in the process of registering or going through candidacy, and professionals that are registered that want to acquire CPDs, or they are continuing their career, or they want to acquire additional skills. And our other focus is on career training. As you might hear in the name, we are very specifically focused on those specific fields where we are focused on people who are professionals. Either they're in work as professionals or they're going through internship of candidacy that we provide. So all our training are geared towards those particular environments. I am going to share my screen and I'll proceed from there, and I'll take you through the actual presentation. Start the broadcast. And I'm hoping that you can see the presentation on your site. You must be seeing a slide that says Sustainable Building Practices, Part 1, Energy Standards. What we going to go through with regard to this presentation is the idea of energy efficient designs. And this particular presentation, as I said, is geared towards knowledge and knowledge building on building inspectors and construction management professionals. And it's specifically going to focus around creating conditions such that when we deal with energy and energy standards, and for those colleagues that are from outside South Africa, there's a part where we're dealing with building standards, and those building standards we have modeled the building standards in terms of the South African building standards. But the South African building standards have been designed borrowing on three regions. The South African building standards owe themselves to the British building standards, building inspection regulation that in South Africa borrow themselves, align themselves to the Canadian and the American standards, and we obviously follow the World Green Building Standards. So they are not. I'm not using them purely because we are presenting from South. I'm using them because they are adapted to there is a global standard that are adapted to the African condition on the main. As a result, they give a basis in which some of this conversation becomes much more relevant. But what we essentially wants to be able to focus on is the relationship between the building form, as we might understand it, the building envelope, as it interacts with its environment, and take into consideration that the world is changing and there's quite a number of things that are happening around us that we need to be able to take into account. As a result, we need to begin to become cognizant of the materials and the control measures that needs to be in place as we do our building practices. Specifically, because we, in the organization that I run full-time, which is BLK Asset Solutions, we've got a division that is called My Home Check that specifically specializes in building inspections and building control. And I know in most geographies and regions in the world, and also in the African continent, that there is now standards that are being introduced, energy standards, where even in South Africa, the buildings are now required to be energy rated. So there's an energy rating that is required for buildings. And those as they develop, they're coming into place, which is some of the control measures we need to deal with. Right. So what are we going to cover today? I'll start off with the introduction and context, and part of that introduction might cover, and also an understanding why does sustainability matters. And now, as I said, I've modeled this presentation around South African context, because that South African context has taken global standards and modeled it so that they fit African context. Secondly, is that most countries on the continent and anywhere else in the world participate in the climate conversations that happens across the world, and they also ascribe to the UN DG goals 2030, which clearly puts out the requirements with regard to energy and the things that are deals with sustainability. And as the focus for today, it's on energy and energy management. And we'll talk about sustainable building design principles. What are those as it relates to energy, and what are those things that relates to energy? I'm not good at choosing pictures, so you'd see that I randomly just choose pictures. Some of them might be related, some of them might not be related to the topic, but it is the content that matter more than the smiley faces that are there. Hopefully, it's an encouragement, the smiley faces, and at the end we'll do a Q&A. We know as a fact that buildings, physical structures, accounts for 30 to 40% of energy used globally. So if you take your home, the heating in your home and energy consumption in your home, 40% of it are consumed by the home itself, by the building itself, whether in water heating, cooking, or all of that energy. And if you look at the use of renewables, or the introduction in terms of the starting of the use of renewables, wind It's still less than 5% that is being considered in renewables. And these are global numbers. Solar, it's about 1% of that. I mean, there's debate around solar more than just the use of solar. It's about the space and the land it consumes, particularly if it's in epic sizes. When it's on roofs, it's easier because it's also saving. But when it starts eating into the land and the natural vegetation, there's debates that are beginning to emerge with regard to that. Geothermal is about around 5%. Biomass and hydroelectricity are far higher in terms of their contribution to the renewal space. And that gives you an understanding to say, how do we begin to address this particular topic in terms of we obviously, it's very clear, and then I'm just laying the foundation so that we get into the topic, is that it is very clear that there's a global shift in sustainability. There's transformation that's happening, and that transformation spans across energy systems. That means renewables, the use of renewables, the increasing use of renewables, business models, circular economy, about reuse, recycle, reuse, and that talks to the circular economy to say to what extent that materials that exist can be reused, can be repurposed, so that we don't have to always be looking for new materials. And in doing so, it will mean that we don't have to keep going to nature to procure materials. We can repurpose the materials that exist. But doing that means that we must be conscious of the lifestyle changes that needs to come in with regard to the way we live, the places we live, and how do we consume the materials that we consume. So there's a big requirement of lifestyle changes with regard to how we live our lives and how do we consume materials that we get out of the climate. And the more and more that we adopt circular economy lifestyles, we beginning to mitigate around climate change and also equally promote equity. We would have seen in many of the regions, we have seen it in Kenya, we've seen it in Uganda, we've seen it everywhere else on the continent, even here in South Africa. I wouldn't call it a specific town, but across the board, whether you are in Johannesburg or you are in eThekwini in the south, we've seen floods and we've seen impacts of climate change, and we've seen incidences that are facilitated by the changes in the climate. And all of these things are impacted by how we deal with buildings, how we design buildings, where we construct buildings, what are the materials we use the buildings, with the main aim, specifically for this topic, is to design buildings and use buildings with the objective of cutting this 35 to 40% of emissions that are generated by buildings, because buildings are the major contributors to energy consumptions, and they're the major energy users. So the more and more we can design our buildings, and the more and more we can use our buildings in such a manner that recognizes the transformation that is happening, recognizes sustainability requirements, is then we'll eat into the 40%. And then we'll see, as we deal with the energy, how do we begin to do that? And I mean, these things don't come easy. We talk about energy transition. We talk about all of these things that needs to be done so that we can deal with the issues of climate pressures. However, many countries, and it's not unique to Africa, but it's applicable to many countries, they face the dilemma of what is called a trilemma, actually. They face this complex difficulty of a trilemma where they have to balance energy transitions, the energy security to affordability, because most national budgets cannot afford, even household budgets cannot afford to transition, because the transitioning or moving towards sustainable uses or climate neutral uses comes at a cost. At the moment, it's still coming at a cost. Yes, we have seen prices of solar PVs coming down. However, if you look at electricity prices have been rising, energy prices have been rising. So there's that trilemma that says, how do you achieve energy security while you are looking to transition and struggling with affordability in order to achieve climate goals? So the balance between energy security, affordability, and achievement of climate goals is a challenge. And South Africa is a typical example where we've got the transition that we need to do. It's called energy transition. We are way dependent on coal. Coal makes up a large percentage of our economy. So because we derive export revenue from coal, not only we use it for energy, we derive revenues in terms of our economy, quite a large proportion of revenues from coal. However, this commitment to reduce the reliance on coal. And what that means is that then we have this headache to say, when we increase towards sustainable measures and sustainable energy sources, how do we deal with this gap that is going to open up with regard to less and less reliance on coal, with regard to our energy and with regard to our financing? So that pressure applies to quite a number of environments, quite a number of countries are facing that pressure. So why does sustainability matter? I mean, this question. I mean, we've had a debate from people such as Donald Trump, where they've pulled out of these climate conversations. Whether it's commissions, whether it's world discussions, the US in this current regime, they've pulled out of those conversations because for them, they may believe, and this is applicable obviously to the current regime. It's not a generalization to Americans in America that the climate conversations are a hoax. It has no benefit. It's moving people away from certain energy sources as a result, but it's not a real thing that needs to be followed. But there is a story for why sustainability matter. Because if we don't take care of this planet, it means that we are living, because we also borrowing, we've inherited this planet from our parents, our great parents, great parents, and then we have to safeguard it so that when we hand it over to our kids, our grandkids, and the generations to come into the future, we hand it over in such a way that it is useful for them. So it still maintains the ability to meet their needs. So we do sustainability not because we're interested in the discussions for the discussion's sake around sustainability and around energy management. We're interested in the discussion because of the impact that it might have. Many countries on the continent suffer from energy shortages, whether it's electricity. Zambia, very recently, they've had challenges the same as South Africa with regard to energy challenges in Zambia specifically, because they've got a hydro power electricity. When the Victoria Falls or the Zambezi River ran dry or ran very low, they had challenges with regard to energy generation. South Africa had, I'm sure many of you, whether you're in South Africa or you're elsewhere in the continent, you would have heard the stories about how we've struggled with electricity for quite a long time, where we started having fancy word around load shedding, load reduction. We played around with English just to comfort people around this thing. And very recently, I traveled to some European country, and I didn't know at a particular time in the day, electricity went out and everybody seemed not to be bothered. And we were told, no, that's just load shedding. So we do have certain times in the day where we manage electricity. So, and that comes at a cost where even without that electricity, the energy prices are rising, whether it's because of the wars that are happening in Europe. They rely on gas, a lot of gas. And then when there's challenges that are geopolitical challenges, they struggle. So the energy prices, electricity prices in our case, it keeps rising, even if you have less of that commodity. recently in South Africa, whether through urbanization or any other measures. We've seen people running around with buckets of water, and we've got this dilemma of water tankers, where people run around chasing tanks in order for them to get water. And I'm not talking rural areas. I'm not talking um, in the peri-urban areas. I'm talking right in the urban cities, including Sandton, where people have to run around with buckets because we've got this water scarcity. And many other countries have got this particular challenge. Now, the challenge arises out of one, Africa is urbanizing. That means the demand for electricity and the demand for water, it's rising. And I'll use the word electricity and energy interchangeably. The reason for that is because we still demand electricity in its purest form in terms of energy needs, but there are other energy needs that are not electricity, which we will deal with, that can be provided in other forms, that we need to look at alternatives in which we are able to deal with this. And the objective being that over time we need to reduce our reliance on fossil fuels. So our reliance on fossil fuels needs to come down. So sustainability is no longer optional; it's an economic survival. Water is life. If you don't have access to water, and some of these water scarcities is because if you don't have energy, you can't pump water, particularly in the urban areas. You can't pump water. As a result, it creates so access to energy is not only about just pure access. It's also about how do you deal with that access. So that just was just laying the foundation in terms of us understanding the environment, understanding how that environment impacts us. And for this is the slide I was talking about, to say it was modeled on South African regulations. But least green buildings standards are not a South African creation, they're world creation. Even the South African building standards, as I said, are modeled around the British standards because we're colonized by the British. So the way we build and the way the British built is nearly the same. And then the American, and with regard to building inspections. So we've got a number of building regulations. And for different countries, I suspect you also have a number of building regulations. Now, in South Africa in particular, we've got what they call national building regulations and standards, right? And for those, you've got a national building regulator. And the national building regulator would be in the Department of Trade and Industry, but the national building regulations, which would come in a form of SANS, which is called SANS, South African National Building Standards. And then you've got SANS that tells us, SANS 1400, and that will tell us how you build. But each municipality, when you construct building plans based on the SANS standards, those building plans are submitted to a municipality, and the municipality approve the plans and eventually use those plans to be able to build whatever that you built. And for every building, there has to be a building inspector that deals with that particular building. So that's when we're talking from greenfield to a completed structure. You have to deal with building regulations and building standards. And these building regulations and building standards, part of the challenge, and I'll talk about this challenge when I talk about enforcement, is because they're sitting in different places, it creates its own problems. But we do have standards, and the standards dictate how the National Building Regulations and Building Standards Act, how buildings are supposed to be constructed and what's the minimum requirements. And those minimum requirements dictates some of these things we can come to. And then when it comes to sustainability, some of these things are built into those standards. And specifically energy efficiency, energy performance sits in SANS 10400. That's where the energy standards are sitting within the South African National Building Standards. So the SANS 10400 deals specifically with energy usage in buildings and all of that, and then we can say XA. So they sit there, and we'll go that into details. So that's the law. But then you have voluntary compliance, right? And the example that I've given of voluntary compliance as it deals with sustainability is the Green Building Standards and the Green Building Council in South Africa, in Kenya, and other countries. They subscribe to the Green Building Standards as is formulated by the World Green Building Association. Good standards. So then the Green Building Standards would dictate that as a member, there is certain things that relates to sustainability that you need to comply to. And we'll go into detail what the Green Building Standards does and what will be the benefit of following the Green Building Standards. So there are things that are in the Green Building Standards that are not in the regulations. So the Green Building Standards, by their very nature, although by industry practice, it becomes the accepted norm and standards, they're not law. They are voluntary in their nature. However, they assist the law in dealing with certain materials or certain items that are not dealt with in law. As it regards, because their specific focus is sustainability and their specific focus is driving green or buildings to be green. That means buildings towards sustainability and towards making sure that those issues that deals with buildings are dealt with in terms of sustainability. So they create the standards for sustainability specifically, and they create requirements in which buildings can conform to sustainability. Whereas the law, the national building regulations and the building standards deals with the totality of the building in terms of construction. It does not necessarily focus on sustainability. It focuses on the construction of the building. It so happened that within the standard, there are certain specifications that would address issues of, in the building standards that will deal with issues of sustainability. The challenge is legal compliance and enforcement. Although it is compulsory that every building from greenfield to a completed structure has different stages in which it must be inspected. That means the inspector must come in, sign off. You do the foundation, they come in and sign off. It's according, your building plans has to be approved, signed off. Before you start building, you have to, your building plans be approved by the municipality or the local government. And once you start construction, whether you live in an estate or you live anywhere else, a building inspector must come in and sign off. At the different stages of that building, a building inspector must come and sign off up until the roof is sitting, and then the final certificate you are issued a certificate of compliance or the certification of occupation. So until you've got a certification of occupation, you're not allowed to occupy a building until the municipality or the building inspector has certified that the building is fit for occupation. That's what is meant, or is fit for human use or fit for use. That's what the certificate is meant for, because it would look at different aspects of that building: energy, electricity, or plumbing, water, and all of that. It will look at different aspects, the envelope of the building, the roofing and the roofing structures, the windows, the glazing, their requirements. So the building inspector will sign that off. However, we know in practice, this does not altogether happen. For many other reasons that could be provided, it's not part of this particular training, that is not provided, but that will be provided. So, and the reason for the lack thereof, we have seen in South Africa, we've seen stories in Nigeria, we've seen stories in a number of countries where we've seen building collapse. And when the investigation comes out on the building collapse, you find that the building was not built according to standards. As a result, there's a big need to work on legal compliance, and this training contributes towards that journey that says that we need to build the capacity of the inspectors to be able to do their work, to be able to understand some parts of their work, as well as the construction people to be able to understand. Albeit this deals with one narrow aspect of that. And that narrow aspect is around, as the focus of this is on energy efficiency. How do we make sure we develop buildings that are energy efficient? And the foundation of energy compliance in building, it's formed on these four things, energy usage in the building. And one of the regulations that have been introduced, and those are regulations that deals with energy usage in many countries, including South Africa, is the building ratings, where energy ratings, where the energy ratings are introduced for the reason that the regulators needs to understand, and they need to make sure that buildings use energy in an efficient manner, in such a way it does not, the carbon emissions out of that building are reduced over time or are within acceptable limits. So that's the goal of these energy ratings. It's about measuring energy usage in buildings over time. Thermal performance requirements are being met, and you're only going to be able to meet those is the mandatory insulation. And very recently, a few years ago, there was two pieces of legislations that were passed, or regulations, around hot water in terms of non-electric sources. So a few years ago, and when I say a few years ago, I think it's around 2007, 2008, if I'm not mistaken, if not earlier or later, but it's around about that time, early 2000s, where there were regulations and act that were introduced that any new building that is constructed, at least in South Africa, its hot water needs, a certain percentage of that hot water needs must be derived from non-electric sources. That means if you're going to construct a new building, that new building, post that period, that new building, the hot water needs must either, and especially hot water needs, we're referring to the geyser primarily, must be from a non-electric source, whether you're going to have a solar geyser, a gas geyser, or some other hot water system. At least greater than 50% of the electricity source for that hot water needs should not be from, greater than 50% should be from a non-electric source. That means if it's from electric source, it must be less than that. Now, obviously, you've got older houses that would have derived their water needs from energy sources. So the idea would have been that over time, as you upgrade your building, you then move away from electric sources for your hot water systems, because we know 40% of water needs or hot water needs in any building is derived from electricity. So you reduce that over time. That means, and that's the foundation for compliance in South Africa. So what does that compliance means practically? It's easy to say energy usage in the building, thermal performance, and all of these things. What does it mean in practice? So first, it's building orientation and design. Now, what do we mean by building orientation and design? Is that the building standards requires a building to be north facing. Now, I've seen practically, at least in the southern hemisphere, that would be a practical requirement for the building to be north facing. I've seen here in South Africa and many other places where like literally a building is in the shade, not because they've built trees around it or it's built between buildings, but the way that it's orientated is that as the sun rises, this building has got a very big shade on so it never gets exposed to light. Your large windows are sitting on the southern side of the building. Now, I'm sure that building is as cold as hell. A few years ago, with very little knowledge, I bought a house somewhere in Ekurhuleni. It's one of the municipalities in South Africa, if you're not South African. And I couldn't understand. I was still a young chap. And there was parts of this house. It's not a double-story house. It's a single-story house, and parts of this house were cold, summer, winter. So when you get into this room, in the middle of summer, 32 degrees outside, you have to switch on a heater. Now, in those days, I couldn't understand. I was just hated this thing and eventually sold this house because it was just damn cold all the time. Pardon my language. And as we got to learn over time, as we got to become the inspector, the technical design of building, architecture, and we realized that this particular building, no matter how building it was, no matter how beautiful this house was actually orientated incorrectly. That's why it was always called, we have to use, so building orientation affects energy consumption directly. There's a one-on-one relationship between, if a building is not north facing, that means the large proportion of the house or a building where you've got your ventilation systems, whether it's windows, and mostly we're referring to windows, glazing, and all of that, where light comes in. And I know I use the word ventilation system, and somebody who says there's an aircon, will come to the ventilation system. But I'm talking on the basis that part of your building design orientation, it's also about where your ventilation, natural ventilation is. Is that depending how you've orientated the building and your natural ventilation, that allows efficient energy efficiency in the building. So building glazing, where's your glazing facing? Impacts on your indoor lighting, indoor thermal thermal levels. It affects how much insulation. As I said, in this particular house, I have to use heater all the time. So the degree to which your indoor comfort, as they call it, is affected by the efficiency of your building and your design. And that efficiency of the building means that somebody at a municipality, when they approved your building plans, even though they noticed that this building is orientated incorrectly, they signed it off. And we have seen quite a number of those. So I don't blame this person that I've seen recently. It's a 3-story walk-up building, student accommodation. It's situated somewhere in Pretoria. Now it's facing a main road, and I hope they wanted to face the main road. Unfortunately, the main road is on the south of the building. That means they forced the building to face south. As a result, this building, whether you pass it in the morning or you pass it in the afternoon, it's always in the shade. It's always in the shade. And worse, the windows are facing the west. The windows are on the western side of the building. So you get half the sun in the afternoon. In the morning, you get no sun because on the eastern side of the building is balconies, and balconies have got most of those balconies have got sort of they are covered balconies, all of them. So essentially, you have to invest in a nice heater for the entire rest as long as you live in that building. And I'm not surprised that the building is half empty, because you'll see when we get to the green buildings that part of the benefits of the green building is indoor comfort. And that indoor comfort has to deal with the thermal mass of that particular a particular building. So energy ratings, which are now law and they're required to be provided. Yes, as we speak now, those energy ratings are enforced on commercial buildings, as it started recently, slowly enforced, let me use the term. They are not necessarily enforced on residential buildings. But as we know that over time, organizations such as the Green Building Society or the Green Building Council are developing standards that will be applicable to residential buildings. At the moment, a majority of those standards apply to commercial residential, but they will apply to individual residentials if you apply them. And slowly but surely, some of these requirements of energy ratings would apply to individual single residentials, as we might call them. It's the same way that cell phones were designed in the old days. Started off as a brick, now we can fit it in our pocket. When big companies design vehicles, they all the best stuff goes to their luxury models, and over time, that best stuff, they figure out how it ends up, how they can make sure that it can arrive at their entry-level models at a much more affordable cost. So over time, I suspect that some of these things, these energy ratings. I know that the energy ratings that we use in South Africa, it's a European standard. We lift and drop European standards. And I know that in Europe, for example, your things such as your smart metering, where the local authority have access to your energy consumption. As a result, you are able to receive notifications with regard to your energy consumption. So how does these things apply to us in principle with regard to building design and practical building use? I mean, if your property is already not north facing, you have a challenge unless you can't turn it around, you can't demolish it. But some of the things that you can use is to begin to change the either the systems within the house, ventilation, to increase the level of natural ventilation that happens. Whether if your house is affected by heat more than anything else, natural heat, meaning there's too much sun coming to the house, is to think about trees to allow for a level of natural ventilation into the property, into the building, and that natural ventilation of such a nature that it minimizes the level of heat that comes into. And there are many ways in which you can direct the nature or the environment around the building so that you can get as much natural ventilation into the building as possible. It doesn't help if you've got small windows. So there are many ways in which you can be able to achieve that. And these things are achieved through different methods that could be used, shading systems, so that you can improve the thermal performance of a building. And these thermal performance can be improved by differentiating how the building is designed. So although the actual design itself, so that compliance that we're talking about right at the beginning, where there is challenges with compliance. If we don't deal with that compliance, there's many repercussions that comes down the line. This is not the purpose of this presentation to talk about what are the reasons why compliance is very low. Other people talk about brown envelopes to look the other way. Other people talks about the pressure from developers to develop and finish their buildings on time, so that they can be able to flock it into the market. There are many other reasons, but in spite of those reasons, is that if compliance is not being dealt with, so that means that the inspections do not happen as they happen, is you get to find out when you claim from your insurance, which is once the building is finished, you now something happens in your house and you get to claim from insurance, and the insurance comes in and repudiate your claim because your systems has not been designed efficiently. Personally, I've had that experience where I had a challenge with my roof, and we'll deal with that when the expert on roof comes in. It's one of the examples where, nice and behold, I go and claim, I've got this particular problem, there's a leak from my roof, da 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 da. The insurance comes in and says, yeah, no, we can see what causes the thing. But unfortunately, your trusses were not designed correctly. As a result, because the design is not correct, even though we can see that the leak has not been caused by the design of the roof. The leak was caused by something else. It was hit by a brick, whatever. Somebody was throwing something, and it ended up on my roof. And they say, in spite of that, because the roof in any way was not designed properly, in terms of the trusses, we're gonna repudiate your claim, right? So now that responsibility to approve that particular roof design would have been the inspector, because my house was built from scratch. So he would have had to sign off. So somebody signed off this roof, and that's what we're talking about, to say compliance is very important. And I'm a senior building inspector in our business, and then I'm sure there are other building inspectors here, and there are also construction people, there are facilities managers, to be able to say, once you have received a system, even if you've got a certificate of occupation, it is good practice to get a building inspector, or if yourself you're able to inspect, look at the systems that are designed, your energy systems in particular, because those energy systems, even if they're signed off, by the building inspectors, even if they're signed off by your engineers, make sure that they perform as efficiently as they are designed. They are performed according to design. Because when we look at efficiency, we look at two things. We look at design efficiency and we look at performance efficiency. Something can be designed well, but it does not mean it will perform well. So you not only, because in most cases we look at the design, we said, oh, this thing is designed the way it should. And we forget that it must perform the way it should. So the energy rating certificates deals with these things to say your energy efficiency designs must perform equally as efficient as they were designed. So you look at energy performance, you look at energy designs, and both of them, you must get efficiency on both. And small is good. You know, going big doesn't mean big is not always big. So these are some of the you've got passive strategies of achieving passive design principles of achieving efficiency that what we have gone through, the orientation, the natural ventilation. Those are passive design things. These are active design things in terms of active efficiency strategies where your lighting, efficient lighting, whether it's LED, smart metering, efficient heating of air and water. I said I'll come back with the HVAC. There are other HVACs that are now available that are energy efficient HVACs. I've recently seen an advertisement where they've got a refrigerator that is solar operated. So you do have those kind of things that are beginning to come into the market. Geysers, at least in as far as South Africa is concerned, we've got our European standard that says greater than 50% of your water heating and your heating systems should be non-electric sources. So heat pumps, solar geysers, gas geysers are some of those. And we have seen quite a big growth. It's a headache for municipalities in terms of the solar PV systems for solar water heating. It works with battery storage, and that's where the cost comes in. We've got a renewable energy integration where your solar heating systems work with your building, so it's an integrated systems. And that's how you achieve the efficiencies. Because to have a solar system that does not have a battery storage, it helps, but you still have to tie back into the electricity grid. What we try to achieve is we want to achieve the less consumption of sources, electricity sources, which are very fuel-based. And so if we're able to reduce that, that is the objective. So these things originally, at least in many countries, are driven by load shedding, particularly on the continent. I mean, I've been to Lagos recently. I'm a South African. As I said, I gave you details about Zambia. It's load shedding. It's a thing. So some of these ways in which we're able to deal with new building materials and we use renewables would reduce our reliance on non-renewables. My last two slides are going to deal with building materials, and because we've got another session as part of this that is done by a colleague of mine. Is a construction a building person, I think, from East Africa. He's a specialist in this. I'm not going to dwell much into building materials because we've got specifically a session where he talks about building materials and he goes deeper into use of building materials. The point I'll make, it's in relation to energy consumption. And that's the point we're making at the beginning, where circular economy, where the use of non-toxic materials, such as low carbon concrete, it also means that you're consuming less energy. Timber alternatives, locally sourced materials, because then they reduce transport requirements. So if you are able to source all your building materials as close as possible to your building site, it would mean that your demand on energy or carbon emission is reduced. So those are some of the considerations in terms of what you look at. You look at recycling the material, particularly if you are demolishing a building and you are going to build a new building, or you are extending a building, or you are building a new building and there's a scrapyard somewhere. It's about trying to use those particular materials that you can be recyclable, and then you are able to recycle into the building. 70% of materials in a building are recyclable. Steel, majority of the materials in any building are recyclable. So they move more and more towards using recyclable materials. Assist the green building. And this as well, there's a session that will be provided for specifically on green building. I just needed to expand on the point around the Green Star rating, that there's more and more, we know the Green Star rating as it applies to commercial buildings. It's well developed, it's well set out, but there's more and more demand for the Green Star rating to begin to apply to residentials, and slowly it will start applying to residentials. And what that means is that these things like the energy ratings certificates would then in the future, not so long future, will be required to be provided for by residential buildings and households. And because the households have suffered with load shedding, some of the move towards sustainability or sustainable materials or sustainable sources of energy were forced by circumstances. The conversation going forward is, how do we achieve some of the objectives or most of the objectives of climate management and to counter the climate change towards net zero without being forced by circumstances? The same way that because there's a struggle with water, there's quite a number of people who are doing boreholes, but that's a forced circumstances. Rainwater collection is very, very low in many urban areas on the continent. Many urban areas on the continent have a heavy reliance on publicly supplied water. So some of those measures, until we get into a crisis, they are not second nature. And we need to begin to make them second nature so that we're able to deal with the challenges that we face, specifically with regard to these particular things. So what are the challenges that for any company or any households, and this says company because most of these things are more endemic in the corporate space as opposed to households, but it might apply for any households, is that the upfront capital cost requires to comply. It's very high, still very high. I mean, the cost of solar PVs, yes, is coming down. And then we understand that there's a higher property value derived from going green, whether it's following the green standards, green building standards. We know that there's those benefits where the cost recoupment happens over time. And that cost recoupment, if you're a commercial building, it will be derived from you've got a better tenant attraction. So you've got a quality tenants, and there's a premium with that comes with that quality. And over time, you are able to recoup that investment that you would have made. But to be able to get that benefit, which you get over time, you have to make an upfront investment. And some of those investments are not small. It's quite a large number. It's quite a large sums that you have to put up upfront. That's one of the disadvantages that not many businesses or companies are able to meet that requirement, and not many households will be able to meet that requirement with regard to these things. So if you don't have water, for example, to have a rainwater collection system, a fully embedded rainwater, a fully integrated and a fully articulated rainwater collection system, it's quite pricey, including having a sort of a fully integrated energy management system in a household and in a company, it's quite pricey. Now, if you're a tenant, you obviously rely on the landlord. And the landlord, part of your cost, they passed on that cost to you as a tenant to be able to deal with that. So it's pricey in that sense that you'd have to deal with that particular aspect. Even though there's an attraction and you get the benefit. I mean, there is real benefits that you get for going green, higher property value. In residentials, I've heard some of the valuers say that you do get a benefit of between 12 and 20%, depending how green your property is. You get that premium benefit. The other challenge that exists is the skills gap. Is not for lack of trying, is that majority of these systems are developed out of the continent. As a result, to implement these systems, whether where you do mega systems are doing the windmills or doing mega solar farms, or doing, you require specific skills to do that. And majority of these systems are imported. As a result, over time, we need to capacitate ourselves to build skills towards this particular benefit. So there's a skills gap that needs to happen so that we can begin to realize these things. However, even with that skills gap, the skills that we have to use them optimally. And some of the skills that we already have within our environment needs to be and I promise to come back to this point about regulatory complexity. Now, in many geographies, South Africa included, is that you've got variety of bodies that deals with building compliance, whatever. In simple terms, so you've got national building standards, regulations. I'm sure every country has got building regulations that they have to deal with. You have to build according to a particular standard, particular regulations. Then you've got what industry preferences, whether it's green buildings, and those things are not necessarily embedded into each other. In very few instances, they're embedded into each other. So that's the first complexity, that you have to comply to the law. And in some aspects of the law might contradict the green building requirements. And somewhere you have to find a balance. Majority of the green building requirements are retrofits. They're not, it's particularly on the African continent, they are retrofits, buildings requirements, green building. Then you find in certain situations where the regulations as they are applied by a municipality and the regulations as they will be defined in terms of science, there are dichotomies. So in the case of South Africa, the national building standards, the people who need to execute those will be at a municipal level. So the municipality must be a one-on-one relationship. But we know it's not a one-on-one relationship because we've seen a number of buildings collapse. And we're not talking about a small house. Here in South Africa, in Nigeria, recently, there's a building that has collapsed. We've seen a number of buildings that collapse because there's this dichotomy between what the national building regulation requires and what the people that are applying them, whether it's the builders or the construction companies, the construction managers, the developers, and the local authorities who are supposed to implement this. And this by itself creates a complex environment. Either you don't know who to follow or whatever to follow. In closing, what are the key takeaways? The first one is the cost versus value debate. What is the cost versus value debate? Is that the sustainability, yes, is expensive, but the reality is that it's got life cycle savings. Reduced operating costs, high asset value. Yes, it's real that upfront capital costs are high, but it's not expensive, because if you look at high doesn't mean expensive. right? Upfront capital cost. Because if you look at the life cycle savings that you procure, that you recoup, and the reduced operating cost and a high asset value that you get at the end, it pays back for that upfront cost. You know, smart buildings. As we move into AI, and we've seen quite a number of instances where, and I know one of the classes, as I said, is going to deal with building materials and building technologies, is that we've seen where technologies are used to construct buildings, both to design buildings and to construct buildings. As a result, we are able to achieve efficiency, both energy efficiency through renewables, but we are able to achieve optimal sustainability of buildings because we are taking advantage of technology. You know, there was a program a few years ago in many countries where they were moving away from incandescent lights to at that point LEDs were not there, but they were moving from incandescent light to fluorescent, and we moved down. Now we're sitting with LED lights. I'm quite sure in the future there will be much more efficient lighting that is better than LED lights, even though at the moment LEDs are your best that you can get. Passive design is foundational. So when this talks, when if I'm an inspector and I go on site and I'm being called to inspect a building, at least in our practice, one of the things that we teach our team is that before you could worry about whether it's a face brick, plastered and painted, and all of that, worry about whether this particular building is efficiently designed. Because I kid you not, 50% of the challenges that a building faces arise out of whether the passive design issues. That at a foundation, and I'm not talking about the foundation of the building, I'm talking at the inset of that building, it was not properly designed. Whether it's orientation, it's whatever elements that are put in, the building systems are not efficiently designed. So the passive design is foundational. You know, there's a joke that says there are certain areas that don't have trees. You don't build trees. So if you see trees, it means you're in an urban area. And I'm sure I've been in rural areas where there's lots of trees. So we need to be able to look at that, you know. And that at least not focus mainly on, okay, your trusses were poorly designed, but the rest of the roof, it's efficiently designed. It doesn't mean it's correct, but it would mean that you have to look at the totality of the design to be able to understand the critique of any building. So we must upskill our teams, and over time, we need to align our regulations, specifically as it relates to sustainability, towards green buildings, because we are able to achieve much more stricter regulations with regard to sustainability, energy efficiency, energy management, with regard to those things. So even if I've got the best system in place, I've got a water heating system that is not electric, I've got LED lights, I've got all of these things. But if these things are not embedded as a system, both in regulation and in behavior or conduct, then we're not creating a sustainable future. And then when you have projects, I mean, at any given time, relook at your projects. If you want to be in touch, to be able to say you want to have a discussion around, green building design, and where you're looking at what are the construction of the future? How do we build green for the future? How do we do those things? Then at any given time, our website is there, landpropertyinafrica.com. You can visit our website and we can talk about sustainable construction and renovations, renewable energy and integration, and then we can begin to talk about those. Land Property in Africa is the organization That's a website for Academy of Construction and Real Estate. And going forward, those are the topics that we're going to be dealing with, as I said, with regard to building material and building sources. All right, I'll stop sharing and then I'll take questions for the remaining of the 15 minutes. My apologies that we started at 1:15. I would have wanted to finish at exactly 6 o'clock, so I allowed the remaining 30 minutes for Q&A, but we can use the 15 minutes for Q&A. And then you are most welcome. And thank you for being able to make this particular training webinar. And then and we will engage. Thank you very much. I'm just going to check in the chat if there's any questions or comments. Right. Right. I don't see any hands raised. Okay. Thank you very much. I guess this is the end. Yeah, go ahead. I can hear somebody wants to speak.
Good afternoon, Mashilo. Thank you so much for this insightful and knowledge empowering webinar. It's not a question on my side. I'm running low on my battery. I'm only at 2%. So it's going to switch off any minutes. But I do have questions that I did notes down. And if you would allow me next week, if I can just ask, I've got about 3-4 questions that I would like to ask next week.
Thank you very much. And in the meantime, you are also welcome to email the questions directly to our office. And then by the time we get to next week, we can also deal with them.
Oh, super. Okay, I think I'm going to do that. Thank you.
Yeah. All right. And part 2, and the reason why I said send them is because part 2 is not done by myself. There will be somebody else who will be doing part 2, some professor who will be doing part 2. But I'll make sure that the questions are dealt with. All right. Thank you very much. Let me see. All right. Thank you for being able to make the time. This, as I said, the focus for today was on energy efficiency and on sustainable building designs. And then next week is part 2, is sustainable building design, and they're dealing with a separate topic. And that is in the series. And after that, the series will continue. This is part of the Building Inspectors Network, running towards a conference at the end of the year for building inspectors and construction managers. En route to go there, as I said, there's about 12 training webinars that will take place. Each of them takes an hour to an hour and a half. And then just watch out for the mails as they go out. Thank you very much. And thanks for making your time. Enjoy yourself. If you have any questions, drop them on our email, visit our website, and drop us. There's a Q&A. All right, I see. Yes, thank you very much. I see somebody says they'll share the questions via email. Thank you very much, Bush, Victor. And then we'll respond as provided. Thank you very much. Enjoy yourself and good evening. All right, let me see. All right, that's the one. Okay, thank you, ladies and gentlemen, and thanks for making the time. Until we meet next week on part 2 and as the series goes along. Enjoy yourself. Bye-bye.